Mm. Oh my God. Um, Heard audio. Okay, so my audio is already on. Hello and welcome to the Side One YouTube channel. It's been a while since I've done a live chat. I have got the Discord up as well, so people who want to talk to me through Discord, that is running as well. So in this video, we're just going to go over a few little projects that I've got currently on the go, what I'm planning on doing, etc. And I'm planning on answering any questions you might come up with at the same time. So this isn't Ask Me Anything, so fire away any questions you might have. So current projects on the go, I've got the Spot Micro, which I've been doing over the last couple of months, and he's coming along quite nicely. Programming is a challenge, particularly for the integrated movement. Preferably don't want him face planting, which he's been doing, or doing backflips, which he's also been doing lots of. And this is all to do with keeping the center of gravity and center of inertia over at least 3 feet on the ground. The other project that's come up just recently is the new InMove hand. So I managed to get into the beta group for testing the hand and checking through the instructions on how to build these things. So I've actually got most of this assembled. It's not complete. I am waiting on PTFE tube still. The PTFE tube that I could get in Australia was either too big or too small. So the stuff I've got is coming from China, and I'm not expecting to see that until next month. I did have the springs on hand. These are available in Australia from, I think you can get them from Bunnings, but this lot I actually picked up as one of these grab packs from Aldi's when they were having one of their special buys. And there's a heap of these in there, so that's worked out quite well for this one. So obviously I've been in with the paint on this one. I thought it might look better to pick it out, but the translucent colour tends to bleed across a little bit more than I anticipated. So one of the things that Gail's done with this design is, one is adding in the 3 wires for the finger sensors, and he's using these little tiny, what are they, AH3503 Hall effect sensors. These are an analog device. I have tested one and they appear to work quite well, so they'll be interesting to play with. I haven't soldered any of these on because I'm planning on pulling all this apart and actually doing a proper build video for it. One of the other things he did do is he changed the wrist arrangement. So in the wrist, previously you had the servo up in the wrist section, and I've got my camera, which I can't move from memory, in this bottom corner. So yeah, he had the servos up in this wrist section, and it made it a little more difficult for everything to get past the servo. So in this new version, he's actually moved that servo back down into the servo bed, or just in front of the servo bed in the forearm, so back around here, which gives a much clearer run for our tendons. The other thing he's done is this time he's added springs into the fingers, so they're always open. And one of the issues we had with the old hand is he had a tendon for open and a tendon for close, which makes sense because that's what's in the human hand. And then he connected those back to the same servo, and that meant you had to keep tensioning the lines, the tendon lines. The issue a lot of people were having is when you move the wrist around, it changed the length of the path that the tendon traveled through, and so would tend to stretch the tendons a little bit or pull on them. and then you'd have them loose in other positions of rest. So this new design overcomes that issue as well. So there's been a lot of thought put into it. Even the way the wires run. So when you look at the bottom of the palm, and I might just pop these screws out so I don't lose them. He's got these traces in here for these wires to flow in, and that keeps them well out of the way. They're easy to get to while you're building, and then that screws on. He's used nuts and bolts through on the fingers. Now in his build, he's used flathead or countersunk screws, and they sit in nicely. These sit in as well. The bulging on the side here is not the head of the screw, it's actually the nut I've used. So he's recommended 15mm flatheads. And one of the things that's different between a flathead measurement and a round head like I've used here measurement, when you measure a round head, you measure from the bottom of the head here to the tip to get your length. But with a flathead, you measure from the end of the screw all the way to the top of the flat head. And you can see there's a couple of millimeters in that alone. So this is a 15mm long screw, and the ones he's recommending are 16mm flathead type. So his screws end up being, to the end of the top here, a millimeter shorter than these. So here's probably a better size than what I've used here. These stick out more here because I've used nylocks. Now the difference between a standard nut and a nylock, and I thought I had nylocks here. I did have a standard nut there. So you can see there's a significant difference in how thick these nuts are. So the nylocks are a lot thicker. I've gone with the nylocks. One, my screws were probably a millimeter or two longer than KL's. And also the nylocks hold the screws. So with the rotation of the finger, it's not going to come loose. During the early stages of printing, I did have significant issues with my printer. It took me a while to figure out what was actually going wrong. RIST is a derivative from Designer of the Nervo board. That's a possibility. I've only been building InMove for around about 6 years, and InMove build predates me by quite a bit. It's interesting. I honestly don't know who designed it. My audio source is probably causing that. Let me see if I can find that. Okay, so if all goes well, CRISPR is controlling the audio level. Martin de Groot designed it, did he? I think I've seen that name before, but I haven't seen a lot of his projects. Yeah. In any case, while the risk setup was reasonable, It was a bit of an issue with the stretching of the tendons. Okay, so I've got the audio turned down a little bit. We'll see how that goes. So yeah, the new design, the wrist gear you can see has changed. He's made where we used to have two holes through, and I think I have got another wrist gear, an original floating around here. So this is an original one, and you can see the difference in them. So what he's done is he's opened up these holes into a slot to make it easier for the ribbon cables to go through. When you're only running 2 wires to your sensors, so a total of 10, you can just get them through that slot. But when you are now running 15, it's a bit harder, so he's opened this one up. He's running a PTFE tube that has an outside diameter of 2.5 millimeters and an inside diameter of 1.5 millimeters. And that fits through these holes quite nicely. You may have to open them up a little bit to the 2.5 with a 2.5 mil drill. But having the PTFE or the tendon inside the PTFE over the whole run also makes it easier to pull the tendon through, which helps a lot. The fingers do operate much better, and I just pulled that out completely, almost completely, because I haven't glued them in yet. There is an improvement on the finger design here on the tip of the finger as well. The tendon comes out here, and then he's got like a V here notch. So when you pull your tendon over, it helps to grip it. And I'll no doubt glue that into place with a bit of super glue. All right, so MRL on a Raspberry Pi is actually easier than ever. It used to be really hard going back a number of years ago. It's now much, much easier to install My Robot Lab onto a Raspberry Pi. The Raspberry Pi OS in Buster is actually very easy. I have got My Robot Lab up and running on the latest Bullseye version of Raspberry Pi or Raspbian. There's actually 2 versions of the Bullseye. There's the standard 32-bit that everyone's familiar with, but there's also the 64-bit now. My Robot Lab does run much faster in the 64-bit, so I will give it that. But in the change from Buster to Bullseye, they also changed the video format quite significantly. The result of that is the OpenCV is broken in Bullseye. So while Bullseye running 64-bit is faster, unfortunately there is no OpenCV in My Robot Lab with it. The boys are planning on going back and refactoring OpenCV a bit more. I know they've played with a lot of the filters in OpenCV already, and they've done a good job of the ones that they've worked on so far. I don't think they've gone back to refactor the video capture on the Raspberry Pi under Bullseye yet. I'd be interested to see how you went with the Bullseye, Tom. I actually did find that My Robot Lab did run faster. Chromium, on the other hand, on the 64-bit, sucks royally. It is slow, very slow. I tried installing the 32-bit of Chromium on Bullseye 64-bit, and it just didn't make it. I'll catch you later, Mr. Van Toon, and we will catch you later. I have had my Robot Lab running on Bullseye, both the 32-bit and the 64-bit version. It does run faster on the 64-bit version, but as I said, there were issues with the OpenCV just not working at all on Bullseye. I have got, actually, I have got Spot online. Let me see if I can bring him up. That one. Right. So that's actually the desktop for Spot. Uh, that's a VNC connection into Spot himself. And that's actually my Robot Lab. I'm not launching the Chromium on that one. Let me see if I can find where I have actually got my Robot Lab running on it. Somewhere I do actually have, I thought I had the web browser set up. Yep, no, my Robot Lab's not an issue to go into. This isn't Ask Me Anything, so I will go in and have a look at a few of these things for you. I don't think I've got a web page set up in my scenes. Let me just add one quickly. It's actually, let's try it a different way. Browse, screen capture. I start with a fresh baked image, as I mentioned, tried Buster and Bullseye. Then I do an update upgrade. Which version of Java are you installing? There are quite a number out there, and the latest version of Java won't run my Robot Lab. Okay, the how to should have worked. I've been through that a few times, and I've actually had to rebuild after I've corrupted my web browser a couple of times. Okay, let's try that one. Okay, so this is actually a live feed from Spot. Currently, he's sitting down, which is why this MPU 6050 cube is on its edge. If I go to Python, crouch works well normally. Why is that not working? Says I'm online because there's nothing in there. Okay, so we can see that that's moved. So let me just bring Spot up on top of my hand. So this is Spot. Might be easier if I actually bring him over onto this one so that you can see the legs move when I execute the commands. So go back to Python, go back to sit, and it's not there either. So that would be sitting like so. All right. Let's go through the basics with my robot lab. The only real difference between what I've built and the ESP32 version is literally the brain in it. I've run a Raspberry Pi instead of a ESP32. There is other code out there for the Raspberry Pi. Some of it's actually probably better than what I've done. I'm still learning a lot of it. First and foremost, I'm more electrical side of things. I am an industrial electrician by trade, and I am learning programming. Python is still a new language, a relatively new language for me, and it's coming along. I found a few little bugs here and there within my robot lab as I've gone. Grog's been good and fixed most of those bugs already. I did find some of the limitations of the Raspberry Pi as well. So the big thing with my robot lab, you've got to make sure you've got the Java installed, the properties, etc. You've got to have a very good internet connection. It does take something like 2 hours to install my robot lab onto a Raspberry Pi 4. It's about 2.5 hours on a Raspberry Pi 3 when you're starting from scratch. So it does take a long time. I don't have an ESP32 cam in Spot's head. Uh, have I got open? No, I haven't got open these. Let's start it up. Open CV. Let's call it Open CV. Or I'm going to use the web viewer and not the native viewer. The native viewer will open it up on the Raspberry Pi's HDMI output, which we can capture with VNC. But we actually want it on the PC I'm using to control it. It is index 0, camera, OpenCV, that all works. We can start to capture, and there it is there. Spot is looking at me from the floor. So if I come back here, you can see the images are sort of in sync. No, I'm in Australia. Um, I'm based out of country Victoria. Beer and chat would be great, but I think there's a bit of ocean between us. Yeah, so as you can see, the frame rate is like 27, 28 frames per second off a standard Raspberry Pi camera connected to the CSI connector on the Raspberry Pi board. That I am running Buster 32-bit in this build. There is a lot of British migrated over to Australia, which is part of our roots. So there was the Aboriginal Indigenous population, then the British invaded, I suppose is the best way to describe it, took over a lot of the lands, and we've had immigrants from all over the world since then. So there are a multitude of different nationalities are now Australians. So there's a lot of accent changes. The original one came from the UK. From Germany. There are Germans around in Australia. I just don't know many Germans. I've worked for a bloke from Czech. I've worked with Russian. I worked with Philippine, Indian, Chinese, uh, some Korean. So yeah, there's a lot of different nationalities floating around in Australia. So we have lots and lots of accents floating around in the country. Okay, so one of the let's shut down Spot. Although the OpenCV is working, I haven't installed any filters. If you do fire up OpenCV on a Raspberry Pi, I do recommend filtering down to a smaller video size. It has got a good frame rate at the moment. That light behind me is not in a good position, but that's just one of the room lights. Actually, let's see if I can get him to crouch. Well, that's interesting. He's crouched, but I think the center of gravity is still a little bit too far back. But it does see a good view of the floor. Now, there is a filter in here called floor. It sort of works. The wire you see to the side there. Actually, I don't like that filter. This one seems to work better. It just highlights it a different color. It was working better when I had it on the desk. The idea of those filters when in a robot is you can see where the edge of the floor is, so you don't run into a wall or run into an object or go downstairs when you're not designed to. Even with that running, and this is still at full size, I'm still getting 24 frames a second. So it's actually pretty impressive. You've got to remember at the same time, I'm also running 12 servo services. I did actually add the mouth control service in. Spot doesn't have a mouth, and that service isn't actually attached to anything else other than the fact that it's up and running. That was just because I needed a handy running Raspberry Pi My Robot Lab implementation. So I just started it. I might just see if I can remove that. Release the service is the one that should get rid of that, and it did. So yeah, this is the starting program for my Robot Lab for Spot, and this is the one I've got up on my Spot Micro GitHub. The instructions you followed for setting up my Robot Lab on the Raspberry Pi, are they the ones that are on original? Or what was the date on those instructions? I did create a new set on my Robot Lab, I think it was last month or earlier this month. Oh, that's a good question. Probably took me 2 or 3 weeks to print all the parts for an InMove arm. Mostly because I work full time, I can only really start the printer while I'm at home. So I was actually running the printer while I was at work. I do sometimes check on my printer, and I can stop a print remotely. As I don't know if you're aware, I do run a Raspberry Pi on my printer, and for that reason, I can actually capture the video stream from the Raspberry Pi that's actually on the printer. And if you look at some of my videos where I actually show the prints, that's actually captured by that Raspberry Pi on the printer. Printing the parts is actually not the hard part, it's actually the assembly. And as long as you've got your printer settings right, you shouldn't have too much trouble. The other thing you need to check is make sure everything on your printer is actually working. Now, I did get caught with that just recently. On the new hand, we've got new molds for, well, these are the new finger molds. This is the simple one to show. You fill it up with the silicon mix, then you put that together. It should overflow a little bit, clamp it, leave it to set. When it's finished, you can then pull it apart. This one also has a provision for a 2mm bit of wire that goes in there to actually put a dent in for the magnet to sit in. This one, that's for the thumb, obviously, and this is for the other 4 fingers. Now, something that he's done that's different compared to the original one was, in the original one, it was, I think all 5 fingers were in the one mold, and that could be difficult to pull apart. He separated each finger out in this large mold where it's all the same. But if your printer settings are not right, you can have all sorts of trouble with your prints. So this is one where the printer setting, oh, I actually had a fan failure. I didn't realize my part cooling fan had failed, and as a result, it warped and lifted from the bed at one end, and you can see that it doesn't look anything like it's supposed to. I was actually having a lot of trouble printing, and it took a while before I actually noticed that the fan was not running. I've since replaced the fan, and the prints now come out. The fan had been down for a while, and so I have had to reprint quite a number of parts. The quality on them just wasn't there. So when you look at parts like this one, you can see how bad the part is in the middle. This one got filed a fair bit, but there's no way they'll fit together. The reprint, uh, once I fixed the fan, solved all those problems, and they've had next to no filing, no sanding. Yeah, OctoPi is a really good program. Um, I really recommend it. I'm actually a patron of Gina. I can't pronounce her last name, but she's the creator of the OctoPrint, and I think someone else is actually running the OctoPi side of it using OctoPrint. Yeah, I really like the program. You can have extras added in. The Octolabs, I've now got it linked to Discord, so whenever I start a print and throughout the print process, it actually posts to my Discord channel under the Sidewinder 3D prints. So you can actually see when I've got the printer running and how the print's going. You can also see what prints I've done. Those same videos that it takes the photos from, I also use as part of the start of my videos where I'm assembling printed parts. So I've got the videos of all these parts being printed. So I'll be able to, well, put together a video of assembling the hand. I will use those in the intro of it. What else was, someone was asking, might have been in the robotics building Discord, was asking about running 3.3 volt devices and how much of a problem it is. It can be a challenge in some cases. Yeah, I will have it up on YouTube at the end of this stream. I don't turn them off, which is handy for people who miss the start of it. And some of the streams I've done in the past, I did servo testing. I think my last stream I ran multiple servos on a PCA 9685, which I have floating around here somewhere. So one of these devices. I use these to drive all the servos in Fred and in Spot. Very easy to drive from the Raspberry Pi. You can also drive these from an Arduino, say an Arduino Nano, for example. And with that, you can also, if you've got the Arduino Mega 2560s in the back of your InMove build, you can actually add in these to provide additional servo controls. Very flexible. The latest versions of My Robot Lab actually allow us to now use the base InMove 2 for a build that doesn't use the Nervo boards. Now, Nervo boards are a handy way of getting a basic control of servos. And look, I don't have an objection to Nervo boards. They are probably a good idea for beginners. I look at the wiring side of it from an electrician perspective. Um, and this is where things are. I've got a different viewpoint on it. I like to put my servo control out closer to the servos, run heavier wires to my servo drives, and then run lighter control wires. There's pros and cons to doing that. There's always pros and cons to everything. One of the cons is uh, the Arduino Mega 2560 can run multiple servos simultaneously while offloading all of the control load, or a lot of the control load, from your main processor in where My Robot Lab is running. So My Robot Lab can tell the Arduino to move that servo from this position to this position at this speed, and then it doesn't have to worry about it, although now they are monitoring it a bit more. Whereas with the PCA 9685, you need to literally tell it every single position you want it to move to uh, for that control. So it does put a little bit more workload on your main computer, which is a downside if your main computer happens to be a Raspberry Pi, which is lacking power to begin with. The Raspberry Pi 2, don't bother with. It's just not powerful enough to run My Robot Lab. It can run it to a point. It's just very slow, not very powerful. The Raspberry Pi 3 does run My Robot Lab. It can, and I have done it. OpenCV is very, very slow on it. Again, it's a little underpowered. The Raspberry Pi 4 is probably the first Raspberry Pi that I would recommend running for an eMove or a spot build. It's got more cores in it and more memory. It's actually the memory that is the big difference with the Raspberry Pi. Uh, having the extra RAM on there allows it to actually do a lot more. Chrome is still a very big power hog when it comes to the processing on the Raspberry Pi. So I think I showed it before. I think my VNC connection has dropped. Let me just get it back up. So that's my Raspberry Pi VNC connection. So I've got My Robot Lab running here. It's literally the only thing running on there. I can fire up Chrome on here and connect it as well. It does work. I'm just not impressed with the performance when it is running. If I have Chrome running on here, OpenCV drops the frame rate down to about 18 or thereabout frames per second, as opposed to the 27, 28 I was getting before. So if I go back into OpenCV, you can see it's crashed and it's going again. I'm putting back into sit. So the frame rate there is 27, 28. Now, if I go back over to a Raspberry Pi, I've just got to find it on my desktop here. Now, if I start Chromium, actually, I don't have to do that. I can go localhost 8888. If I switch back over, you can see the frame rate has already dropped, and that's just starting my robot lab up. Oh, not my robot lab up, starting up Chrome. So you can see it's already dropped the frame rate quite significantly. And if I fire up the native viewer, it'll actually hit harder. Frame rate's down to 17. So yeah, it is actually surprisingly quick. I thought it'd be a bit lower than that, 16 frames per second. Now let's turn the native off. That brings us up to 21, 23, 24. And then if I close down Chromium, we get back up to 27. All right, so that's where I'm at with my current build. I'm still waiting on parts for this one. The springs can be fun to install. I know one of the big questions I had was the little screws at the ends. Actually, let me just switch back to my desktop. Getting back onto the hand side, there's a little screw up on the end here. This is not the one that Gael recommended. He used the little screws that come with the small servos. He's got a heap of those left over from other projects. I didn't happen to have any left over from other projects. I have attempted to build Shido's iMech, and I think I put all of the little screws I had into that. But what I did find on eBay was this pack of screws, and in it it's got a M1.4 by 3 millimeters long screw, and that's what I've used in here. There is, and it's near impossible to see it. I have been using a magnifying glass to look for it, but there is a small hole in the print right there. He recommends a 1.5mm drill bit to open it up. I'm using a 1mm. Be careful not to drill through your wires, and then put the little screw in there. The method he's used, which is actually a little bit easier than what I first tried, is you put your screw in here, you get your spring, you have a 300mm long piece of the fishing line, loop it through, giving you a 150mm worth of pull, feed that up through the finger, hook it over the screw at the end, and then pull it up and put the screw through in here. And before you tighten your screw down, remove your fishing line. Nice and simple, very easy to do, sort of. Once you've got that in there, I haven't got the pins in this one, but he does recommend putting pins in. Now this is actually a paw print of the fingers, so I will be reprinting those. In fact, I think I have. I'm just not sure where I've put those parts yet. And he's put nails, pins. This is actually a little bit of fencing tie wire. Goes through the hole. It does the same job. So he's got a whole procedure to actually set different tensions. So when the instructions are available for, and I think he's putting that one, the instructions through the behind a paywall. So the files will be available to download, but instructions on building will be behind a paywall, is my understanding. But yeah, It is actually not too bad to build. Quite easy. You've just got to get your printer settings right. All right, so I have got a new set of instructions that I put up. It was either the end of last month or the beginning of this one on setting up my robot lab on a Raspberry Pi. I created those instructions going back probably February, and they've been in the Spot Micro GitHub for a while, and I did upload them into the My Robot Lab site uh, earlier this month, late last month. So the image that, or the pictures I show in that one, actually go back to a fairly older version of My Robot Lab. In case anyone's wondering, the version of My Robot Lab running on Spot is actually 808. There are newer versions out, I just haven't tried them yet. I was going to bring Fred up and show his video, like show the My Robot Lab running on Fred, but his Raspberry Pi is not running for some reason. It's like there's no power in there. So I'm going to have to have a look at that. I'm seeing a light in him now, so we might start up and give him a, just have a look and see if he's online. Yeah, I'm not seeing online at this stage. Oh, hang on, no, he's just come up. Let's have a look and see what I have got on Fred. All right, so I have got 808 on Fred. We'll open that up rather from my webcam feed. So I'm just going to start My Robot Lab. So on My Robot Lab on a Raspberry Pi, we are running it in Linux, so therefore the // says look in the local directory for the command I want to run, and it's myrobotlab.sh, which is a shell command that we want it to run. If you don't use that // first, it won't look in the local directory and it won't find it. I've learned that one the hard way as well. Now this is a default setup for My Robot Lab, so it will launch Chrome from memory on the Raspberry Pi. When I'm happy with the configuration, with the way Fred works using the I just got full screen in there. So when I'm happy with the way it's configured, I will probably configure it to not launch the Chrome web browser on that Raspberry Pi, and I'll use it from a PC instead. Okay. So it is running slow on this. It started the audio player, and I don't think I've got audio plugged into him at the moment. Let me have a look. Actually, I do have it plugged in. HDMI capture audio is on, so in theory it should work. But it hasn't got anything to play at this stage. All right, so one of the things that InMove does is by default it's going to look for the two Arduino Mega 2560s, which assumes you have the Nervo boards attached to. This is a good thing for a beginner following the tutorials from the InMove website. So I'm not going to suggest any changes to the way this works. I think it's actually well done. I do suggest people building the original design and then coming back for their second version, trying modified versions like Freddy's. We have controllers, and one of the first things I've got to do is create a controller, which is not going to help me because I haven't got a Raspberry Pi listed yet. So let's go to runtime and create the Raspberry Pi service. All right, so if we go into the Raspberry Pi service and we scan the bus, we can see we've got 68, 70, 40, and 41. Now, 68 is an MPU 6050 located in his head. 40 is the PCA 9685 located in his head, and 41 is the PCA 9685 located on his back. The next thing that we need are the controllers. So I have got, I better install those PCA 9685s. So the PCA 9685s use the Adafruit 16C servo driver in my robot lab. So I'm going to call this head PCA 9685. And I'm also going to create, while I'm here, a second one, which is going to be back PCA 9685. So let's go to the head. It's on 40, bus 1. If you're connecting one of these to an Arduino of any type, make sure you set that to bus 0. But on the Raspberry Pi, we need bus 1. Okay, so that's attached. We've got to do the same thing for the other one. So it's Raspberry Pi, bus 1 for a Raspberry Pi. If you're using an Arduino, again, bus 0. And in this case, we're using 41 and attach. So we've now got the two servo controllers in there. I am planning on putting a servo controller in each forearm. So there will be 2 more to be added later on. Right, so let's go back to IO1. It's still set for controllers. All our controllers are turned off. So controller left and controller right are both the Arduino 2560s. I'm going to use controller 3, so turn it on. When you click on port, it gives you a list of ports that are available. So AMA 0 is actually the TTL serial port on the GPIO header pins on the Raspberry Pi, and I'm using those in Spot, but in this case I happen to know it's plugged into the USB port. And connect. If all goes well, it should come back and tell me I have a Nano there, which it's done. All right, so let's go back to I/O. So that's all configured now. Let's go to head. We're going to activate the head, go to settings. Now in version 808, there is a bug. If you turn something off, it will actually release all the devices it uses, including shared ones. So just be aware of that. I think that's been fixed in version 812 or better. So we've got the head, and we've got eyes X and eyes Y, or IX and IY, and we've got right head and jaw. So let's start with the jaw. Okay, so before I do anything with moving the jaw, we need to connect it to the appropriate servo. And now, as you can see, this is, I think, a bug. It's saying detach, which indicates it's attached, but it's not actually attached to anything. There's no controller there. So we need to click on detach so we can actually play with this. So I think this one's a bug, and I'm not sure if it's been fixed or not. In this case, I want to connect to the head, and from memory, I'm on pin 9. And now we can attach. But before I attach, I want to go to basic, go to limits, and I've actually got a different range of limits. And I haven't got them open locally. Servos, configurations I want. 7140. So I need to change that. The 140, and I need to change that to 70. Now this is important for my build. If I try and move the servo, so enable the servo and move it with the default settings, it does break stuff. I've already had to reprint parts. Now I can attach. Now, let me see if I can get this other camera. So in theory, when I do get in talking, I think I've got a loose part in there still from when it broke it originally. But that is working. So I've done no programming as such. I've started a basic My Robot Lab. I've configured the extra components I needed for my build, so the Raspberry Pi service, the head PCA 9685, and now I've told it to connect the jaw. And really, it's not that hard to do. You just got to be aware that you need to do that. And this is using the new eMove 2. So the new eMove 2 program is far better than the one that was in Manticore, the eMove 1. In the eMove 1 the version, you could not use a Raspberry Pi in a set of PCA 9685s. Everything was hard coded. So in the new one, it is far better. We can now click on Save Jaw Config. Camera's still tilted somewhat. But yeah. All right, so the next thing we want to look at is the rot head. If we go to Control, and in my notes, I've got it in a completely different place because it's the most inconvenient way to do it for me. I've got it under neck config. So in my original set of diagrams, I did it as head yaw. It has a min position of 0, a max position of 180, and it's on pin 8. So again, we have to do a detach. This will be connected to the head PCA 9685. It was on pin 8. Show the limits. So 30 to 150, I can actually cope with that. So we'll attach. He's got speed control set fairly slow, 45 degrees per second. That's not too bad. I can actually open this up a little bit more. I might take this to 20 at this end, 60 at the other. Give them a little bit more speed. And that seems to work quite well. So let's save that config. Now, when it comes to the eyes, X and Y, it's a little more complicated because I've actually got 2 servos for each eye. So again, back to Control, detach. Select in this case, I'm selecting the head PCI. I'll need to go and have a look at my original config because I can't remember it off the top of my head. So the one I'm playing with at the moment is the Y-axis. So I'm just going to look at the right eye for the moment, which is on pin 14, and I'm using the full range. So pin 14, I can attach that because I'm using the full range. There's no setting in there that's going to cause me an issue. We'll open up the limits. In the original design, if you're using the mechanism that Gael put in the original eMove, you will need to have your range limited. But in the Dakota Advanced iMac, which I've used, you can have a little bit wider range. So I'm not going to go the full range that I'm allowed, but I will increase the range a little bit. I'll take that up to 150. BI is working. I may need to adjust that upper limit, I think. All right, so there is a workaround for if you've got two separate servos for the eyes. And the solution is get back into runtime, servo, we'll call this one eye left, and we'll call it Y. I know I can't spell for crap. I'm going to remake that. Release that. That looks better. So control basic. It will be the head. It's on pin 12 and it's inverted. Limits, we'll do the same for now. No, it doesn't actually have the ability to link there. Now, this is where I'm going to have to refer to some of my other documentation that I have. There is a command in the servo service that allows you to sync servos together. So let me see if I can find that command for a sec. Okay, so it's a Python command that we can use. And it's just called sync. So we have our iServo left. So if we go to Python, I left Y dot FYNC. And I didn't type a single thing then. Dot FYNC. I01 dot head I Y, and then execute that. I have an error. Oh, was looking for it. I thought it's looking for it as a service, but it appears. I will see if that works. No, I'm going to have to investigate this one further. Oh, it's looking for the actual service. I thought that was it. That's new. I didn't know about that one before. Properties and subscriptions. I used to have a bit of an explore sometimes. Show peers. I'm going to have to explore that one. It is possible to sync them. I haven't done it before, but it is possible to sync them. It is one I'm going to have to try and figure out how to do that. There, there is a way of doing a service lookup, and I did do that in the Spot program at one stage. Do a service lookup. So let's have a look and see if I can figure out how I did it. There is a command that will let you get a service handle, so to speak, just off its name. I did use it at one stage to try and might have been when I was setting up the servos. It's called runtime get service. Let's give that a try. Okay, that appears to have worked. So in theory, if I go to the head left, and it's not working. I've synced it the wrong way. All right, I shall have to sync the other one to it, but it is possible to sync them. So instead of syncing left eye to the head IY, I should have synced head IY to eye left Y. So that's something I'll have to remember for the future. So I won't save this config today. Now that I know how to do that, I'll sync it the other way when I do the other one. I've still got to set up the X axis as well, but it is possible to make things work together. All right, so where are we at with the stream? And I'm all on my own. So I might call that it for the day. And we'll see you all in the next video.